Let's review using the elimination method for solving a system of equations. In this particular problem, we're going to have to use multiplication to get the opposites that we're looking for when we do elimination. We like to play the wouldn't it be nice game. And what I notice is that it would be really nice if I had a 3 here, because then I would have opposites. And I can do the elimination method. Keep in mind, we're not allowed to just stick a 3 in there. We have properties of equations that we need to follow. So even though I can't plug a 3 in next to that y out of the blue, what I am allowed to do is I am allowed to multiply the entire equation by 3. Now the way that works is kind of like the distributive property. We multiply both sides by 3, and in particular when we multiply the left side by 3, we have to distribute to both those terms. So that's going to change this system. The top equation is going to become 3x minus 3y equals negative 9. We didn't do anything to the bottom equation, so I'm just going to rewrite that. 5x plus 3y equals 1. And so what we've created is another system which is equivalent to the original system, but this is going to allow us to use the elimination method, right? Because now we have those opposites on the y terms and we can add straight down and all kinds of good stuff is going to happen. So this is the system that we want to solve because it has the same solution as the original system. So let's go ahead and do that one. So we've used multiplication to change the top equation. In particular, we wanted to get opposites in the y column, negative 3y and positive 3y. So now we can do elimination. Remember what that means is we're going to combine these equations by adding straight down, and that'll allow us to eliminate the y variable and solve for x. When we add straight down, I get 3x plus 5x. That's 8x. The whole point of elimination is to eliminate one of the variables, in this case y. Negative 3y plus 3y is 0. And then over here we get negative 9 plus 1, which is negative 8. We're going to divide both sides by 8. And we find out that x equals negative 1. Now at this point, we need to take this x coordinate and plug it into one of the other equations so that we can solve for y. And my rule of thumb is if I can find an equation that has all positive numbers, I usually pick that one. So in this case, that's the bottom equation. It's going to be 5 times x, but instead of x, I'm going to plug in negative 1, 5 times x, plus 3y equals 1. That's the equation we need to solve. Okay, so let's just clean this up a little bit and then we'll get one more slide to finish it off. When I do 5 times negative 1, I get negative 5 plus 3y equals 1. That's the equation we need to solve to get the y value. And we'll do that on a clean slide. So we're solving negative 5 plus 3y equals 1. We're going to use inverse operations. We're going to do plus 5 to both sides. And that gives us some good news, right? This is canceling out. We get 3y equals 6. Divide both sides by 3. And we end up with y equals 2. So that's great news. We now have a y coordinate to go with our x coordinates, so we've solved the system. The solution is going to be negative 1 for the x and 2 for the y. That's our ordered pair. And that's the solution to the system. That's the place where the lines cross. They cross at negative 1, comma 2. This was the elimination method where we had to multiply one of the equations so that we could get opposites, which is what we need when we use elimination. Good luck with your elimination, and you'll probably hear this voice again for the next video. See ya.